This panel is Space, a $1 trillion market, and it's going to be led by our moderator here, Jeff Matthews. Jeff Matthews is a specialist leader at Deloitte, and he has 16 years of experience in finance, innovation, and business development in the aerospace industry. And he's from Boston University. So I'll go ahead and hand him the mic, and we'll start with this panel. Thank you.
Thank you so much for joining us today. I don't know if that's actually, oh, there we go, much better. I'm just going to say that that was not my decision to delay lunch, so please don't blame me on that one. I would never want to stand between people and food. So we've got a good panel here today. I'm excited to be back here in Seattle for the first time in probably a couple of years to talk about how we actually can incentivize and create a global space economy that's really transformative in its economic and industrial-based impact. We've got a good group of panelists here. I'll have them introduce each other in just 1 second. And we really look forward to a lively discussion, I think, around what has become a very hot topic over the last little while as more companies get started, as more venture capital flows into the industry. What does this really mean from the global space economy? Where are we going, and sort of how do we get there? So to that end, I will let the various panelists introduce themselves and their quick background, and we'll get this panel started. Sunil, if you'd like to go first.
Sure. Thank you. Thank you, Jeff. My name's Sunil Nagaraj. Perfect. There we go. Sunil Nagaraj with Ubiquity Ventures. Third or fourth NewSpace conference. Excited to be here. Excited to be a part of the event. At Ubiquity, I run a seed stage firm that invests in software in the real world. That means software used to sit between a keyboard and a screen, and now it sits between a lot of different things in the real world. And so I think of satellites and rockets as one example of that. Previously, I spent 6.5 years at Bessemer, where I helped to lead our space investing practice, invested in companies like Spire and Rocket Lab and Terabella Skybox.
I'm Greg Autry. I'm with the University of Southern California, where I research entrepreneurship at the Lloyd Grive Center. I've used the NewSpace industry as my research context for about 16 years now. They used to laugh at me when I said NewSpace back in 2003 or so. Not anymore. I'm also recently served on the transition team at NASA.
Great. Chris Green. I'm with the Washington State Department of Commerce. I lead our state's Office of Economic Development and Competitiveness, which includes our key sector program. We typically have an aerospace sector lead, which we're currently hiring right now, that would have this space as part of their portfolio. So basically what we do at OEDC is we work on business development for the state. So we help small companies learn how to export, bring small companies to market. We'll be in Farnborough next month with about 20 companies, helping them engage with big suppliers overseas to try to get contracts. We're also trying to bring investment back this way. So all of our business development work that we do, encouraging companies to grow and expand. We're doing quite a bit of work right now on preparing for the potential for Boeing to announce a new middle market aircraft. So we're doing a lot of work on that. And we're just, finally really excited that this conference is back here in Seattle. We think there's a lot to be excited about here on Washington State, and glad that you all take a few minutes to listen in. Thanks.
Thank you very much. I'm just really happy to be back in the land of caffeine. Anyway, so a little bit about me. So I, as the introduction said, I'm actually in my 17th year of consulting right now. And when I was probably 8 years old, I just wanted to be an astronaut. My grandfather served in Mercury and Gemini and worked on Apollo, and I thought that would be the coolest thing ever. Only I was bad at engineering, and he will absolutely agree with me on this one. And I was horrible at probably doing anything that an astronaut would actually be required to do. So I became a finance major. And to echo off of Eric Fisher's comments earlier in the opening keynote, this is an exciting time to be in this industry. If you'd asked me 10, 15 years ago, I would not have imagined I was sitting up here with a Big Four consulting firm talking about space and how we can drive towards a $1 trillion market. This is, I think, truly transformative, and I think it shows very well by the turnout that we have here and the fact that you've got different industries and different leaders and everybody else that sort of come together around this topic. It's something that I've been thinking about for a long time. So for the past few years, I've done a lot of economic and market studies, and really it comes down to, if someone asks me what my measure of success is in the space industry, I'm not going to be an engineer. You don't want me bolting anything to anything or flying anything else. You don't want me probably doing some research experiment in space. But if I really had to think about it, the one thing that I think I could help do and be successful is help grow the space economy and the space industry. What can I do to empower structural change? What can I do to help get this rate of economic growth to be faster, more sustainable, and more impactful? And if I can even push the needle just a little, then I think I've done a good job. So I'm excited to be talking here today about that. To give some background, and let's see if the clicker works. There we go. Here's where we are right now, and here's what everyone is sort of looking at. So this is a slide that was compiled by the Space Frontier Foundation that aggregates the current space economy and 3 different outlooks from Goldman Sachs, Morgan Stanley, and Bank of America Merrill Lynch. So depending on which source you use, the space economy right now is about $330 to about $350 billion. And it's been growing towards that level at approximately a 6 to 8% compound annual growth rate per year for the last decade or so. It's significant, but what we don't know about the number is where exactly it's going and what we can do to incentivize it to get there. So keeping the sort of linear growth curve, it's nothing wrong with that. The industry is growing. People are entering the industry. New business models are being created. But what happens if you really start doing something transformative? In 2017, the investment banks actually started looking at that, about what the future of the space economy could look like. And as you can see, we've got 3 projections there. And from a left to right perspective, they were all done in 2017, but this is the order in which they were released. Goldman Sachs pegs it in the 2040s at about $1 trillion. That's an estimated annual growth rate of 7%. So a little more than we've got now, a little less, depending on how you slice and dice it on a year-over-year basis. Morgan Stanley took a look at it and did an interesting job because they gave a most likely outcome along with a bear and a bull market outcome. So their most likely outcome, $1.1 trillion in the 2040s, with an estimated annual growth rate in the bear market at 3% and the bull market at about 18%. And then Bank of America took a look at it in late October and came up with $2.7 trillion with an estimated annual growth rate of about 25%. And obviously, we want to skew towards that $2.7 trillion part. But one of the challenges in looking at how we get there, how we incentivize it, and where we go from there is how you slice and dice those numbers. So for example, in the Bank of America report, which if you haven't read it, I strongly suggest the 110-page read, it looks at what you can do from encapsulating the entire economy. So it's a cislunar economy. It looks at the different enabling technologies, where we're going and where we can get there. If we can do that and we can realize this 25% annual growth, this industry is going to be in pretty good shape. But what if we could actually do something a little more transformative and talk about some emerging trends that could accelerate that? In the 2040s, I know I'm personally close to retirement age, and that's not a bad thing at all, but I would like to see this be incentivized and pushed forward faster. And I think some of the topics that we're going to talk today about the space landscape will identify some areas in which that can possibly go forth and make a difference in that regards. There are several paths to pushing these numbers forward, or at least realizing them faster. So path 1 is, what's the business model that closes that really creates a transformative and economic impact? And the one that gets quoted in the news often, space resources. There's been multiple quotes from people that say the first trillionaire on Earth is probably going to be made from asteroid mining. And I don't necessarily disagree at all. But that's a single piece of the space economy, which I hope gets realized, and I hope gets realized soon. But what if that gets delayed? Or what if we don't put enough into the rest of the technology development, the economic development, and the sort of entrepreneurship support to actually get that there when we want it and where we're going to go with it? So first trillionaire in space is great. I hope it happens. I hope it's someone in this room, actually. If it's me, you'll all know real quickly, by the way. I will make that known. And it's not going to happen. But the second is, what can you do from a tangential industries and technology? So you look at the money that's pouring into 5G. You look at the money that's pouring into geolocation services. What can you do to really tie space to that? And where does that help drive the economic growth of the market? And I'll give you a little side note on this one when we talk about markets and everything else. In 2013, there was a study done for Google, and it looked at the economic impact to the U.S. economy for geospatial services. So that includes everything from your phone's ability to tap into Wi-Fi beacons and figure out where it is, all the way through space-based position navigation, timing, and GPS. It adds $7 trillion of economic value to the U.S. economy and the U.S. industrial base on an annualized basis. And that's a large number, but that's just a small portion of the space segment and the space economy. So how do we drive more significant and transformative change that actually enables more technologies and more sort of use cases that have that kind of large economic impact? That's a discussion that's hard to have, but I think us as an industry is finally prepared to have it. And third, what can you do to enable structural change? And by structural change, I mean significant market change that transforms the demand and the supply curves, looking at it from an economics basis. And I'll give you a good example. Elon Musk is landing rockets. He's recapturing them and reusing them. There's an example of where we're driving towards some significant structural change right now. The fact that Elon's not the only one. You've got Jeff Bezos and Blue Origin up here that's looking at reusability. You've got software-defined CubeSats. You've got the miniaturization of hardware. And those trends are going to help drive significant change within the economic framework that we consider the global space economy. So there's a lot of moving parts, and I think today we'll try and dive into some of them. We probably could do an entire lecture series on this, so we won't lecture much more than my next couple sentences. But what I'm going to do is ask my panelists in just a second to give me their view of space as it pertains to their individual jobs, and two specific questions. What does $1 trillion space industry look like to you? And I want that from your specific viewpoint and what that looks like from your roles and your experiences. And if we're at $330 billion right now, where do we go from there? So if you don't mind, I think we'll start with Chris. I mean, seeing that we're sitting here in Seattle and $1 trillion space industry could really change the economic and the industrial base, and to the point that maybe there's more Boeing factories for space that are sitting around here that look just like what we're seeing behind us. What does that look like as the economy grows for this region?
Yeah, well, thank you. So, I mean, without a doubt, Washington has had great success over the last 100 years in developing just the commercial aerospace sector. And so, we've just released a report recently done by the Teal Group that talks about our strength in that sector. And when we think about that sector of aerospace, we've over 100 years, 1,400 companies we've got in the supply chain across a variety of different verticals within commercial aerospace. We think there's a good foundation and base here. But when you think about the emergence over the last 20 years of new space, from a commercial space to the new space, we think there's an ability for that new industry to transcend a multitude of industries. And so when I think about how that's going to go, how it's going to get to $1 trillion, I think about probably two main things. I think about one, the experience, the depth that we've got in a variety of companies around Washington State, and not just the materials. We certainly think about composites, we think about other advanced materials and the science and research that's going on at some of the universities here, but we also think about computer science. We think about the strength that the state has in those areas with two of the biggest monolithic companies in the world, and Amazon and Microsoft right here. We think about the work that they're doing. And, when we talk to space companies, and I was talking to one, I was just touring one, a month or two ago, what I heard from them is we need more computer science degrees in our employment chain, than production workers. We need a variety of different kinds of folks. And so I think there's an ability for us to think about that, harness that, and I think from the state's perspective, and a role the state has is how do you continue to help and support and build an ecosystem where you create the folks that can do, and perform a variety of those jobs, all the way down from the production workers, folks that do machining, that need those, quick, repeatable, high tolerance parts that are going to go into a lot of these rockets and things that are developed, but also, the artificial intelligence components of this, the IoT components of this, some things that, Seattle's fortunate, Washington's fortunate to be on the cutting edge of. But those are the kinds of things that I think we've got to continue to build and grow, because we've got to have people to build this stuff. We've got to have people to engineer this stuff. And so focusing on that, I think, is going to help be a part of the pathway to $1 trillion industry. And in addition to that, I think about the way space is going to transcend a whole bunch of different industries. And so taking advantage of some of the abilities we've already got here in the state, and leveraging those, I think is going to be really important. Whoever can figure out how to leverage engineering correctly, leverage those skills correctly, and think about the next advanced material that's going to help this industry move forward, or the correct energy and propulsion system that's going to be economical, to your point, I think is going to be critical. And so, from our perspective, helping maintain an ecosystem that is competitive, but build one and keep growing that, and focusing on STEM education and those kinds of things are going to be really critical. And that's a role probably for a good role for the state.
And to add to that, Chris, I really like the fact that you used the ecosystem terminology, because I think over the last so many years, so many people have focused on the strict development of just an aerospace cluster, and they look at the gross, dollar input versus dollar output. And not that that's a bad thing. That's a huge component of economic development. But to really sort of incentivize change, we really need to look at it from an entire ecosystem and what are the companies, the people, and the personnel that can both be tangential to space but be affecting space. And I like the fact that Washington State's looking at that, and I'll fully plug the fact that I actually just finished a study for the state of Arizona looking at the same thing. So it's nice to see that there is an ecosystem focus, coming across in some of the many sort of tech and space hubs. So, Greg, I'll ask you the same question. In your background, what does the trillion-dollar space industry look like for you?
Well, I think one of the important things to look at is first, if you look at those existing numbers, this is almost entirely two things, government and communications. And I don't know that either of those are continually scalable in the way that the projections suggest. So I don't know that you get to $1 trillion market if there's not an inflection point that obviously most of the people in this room think is coming. When I was a freshman in high school, the early microcomputer industry was just beginning. This was like 1976. I hate to date myself here. And the Altair computer had just come out, and Apple was switching from the Apple I to the Apple II. And my buddies and I were enthused in the same way that a lot of young people are enthused about the new space industry. We knew this was going to be the thing, but we were completely unable to communicate, for instance, to our parents or teachers about why this was going to have any impact on anybody's lives. We foolishly, my buddies and I, decided we would start a computer company, and we quickly learned that although we could wire wrap up some microprocessors and some DRAM and make a computer, we were incapable of manufacturing or marketing. So we decided we'll go into software instead, because that's easier to do. And the market we went into was the one that we liked, which was games. And nobody would have seen, but games were the driver behind that industry, and nobody expected it. Everybody looked at computers as scientific and accounting tools. And it was really games that drove the early microcomputer industry and continue to this day to drive the PC business and the internet business. It's entertainment and games that demand processing bandwidth and graphics capabilities. And I think we haven't seen yet what that app is on the NewSpace side. I'm confident that it's there, but I think the most important thing we need to do is not try too much to define the roadmap too detailed. And I don't want to say where you're going isn't valuable, but we need to be careful to realize there's going to be some really unexpected detours, and it'll be interesting to see what they are.
I absolutely agree on the unexpected detours. I mean, I think if we were to just sort of graph out the projection over the next, 10 or 20 years and expected it to follow exactly what we thought, we would be falling into the traps that so many other industries have as well. You brought up the concept of like, what is this sort of app, or what is the driving force of it? I mean, to a certain extent, I've had a lot of conversations with people over the years about, what is essentially the app store for space, and whether that can be, downstream applications that get data into the hands of the largest amount of users, or whether that's the enabling thing that allows, say, the multiple greatest use cases on orbit. And I think when someone finally cracks that, whatever that app store looks like, you will see some of that actual change sort of play out. Sunil, same question.
So I think I agree with Greg insofar as sort of slicing up the larger industry and saying most of it really is government and comm. That's people fighting and people watching TV and people communicating, which is great. And a lot of folks here are focused on Earth observation or remote sensing. I think one way to look at it is by slices. Another way I think about it is maybe number of satellites. Something like 1,200 satellites. And so does it get to $1 trillion by sort of tripling that? So 3,600 satellites, Does it get there because of these mega constellations? Does it get there because there's sort of more volume of stuff in space? Well, I'm a little more skeptical on that, and so I've received pitches from several companies doing components for satellites, and to date have never invested in one. Propulsion or other sort of componentry within a satellite, because I don't, other VCs disagree with me, but I don't know that there's going to be 10,000 satellites or 20,000 satellites when you look at $1 trillion. Rather, I think the direction it's going to come echoes some of what you just said, Jeff, that there will be downstream applications. And I don't know how bankers sort of slice and dice the market, like how much downstream you get to include, but one example that came to mind, I think, 2 or 3 days ago, Cape Analytics, which I always understood to be a space company, Cape Analytics announced raising some more money, and in the news now they are an insurance technology provider. And I believe what they do is use machine learning and geospatial imagery to provide underwriting information for homes and roofs and things like that. So this is a space company that it's a cliche, but has brought space back down to Earth. And so the more of that we can do, more sort of easy to understand down to Earth applications of space is actually what's going to drive this, in my opinion, versus pushing more satellites. And I know, SpaceX and OneWeb are pushing on that direction, but I mean, just scaling the 1,200 today, I don't think will get you there. I think on the application side, I'm starting to see more and more pitches and startups speak the language of customers, and so it really. The companies authentically describe themselves less as space companies. They're really focused on, take something crazy like microphone manufacturing and how that can be, and it uses the internet, and it uses factories, and it uses space, right? And I think if we can include those figures in there, then I think we can see more of this growth.
No, I think that's a sort of great viewpoint. The Space Frontier Foundation did a study last year that said if you could actually unlock all the latent demand, so ignore the fact that this is could potentially have other implications, but over a 10-year time frame, there could be potentially up to 27,000 satellites that are at least earmarked for production and launch, and that's a staggering high number. And that's definitely not going to drive some of that large-scale economic change if they're all trying to chase after the same portion of the market, whether it's comms or Earth observation, remote sensing, et cetera. One thing that you brought up about the downstream applications. One of the best reports I actually ever have read in the last couple of years talks about when you slice and dice the economic numbers and also the use and the value of space data, about the diffusion of space technologies and space data into other industries is one of the hardest things that the space industry can actually go quantify and qualify. And so because of that, a lot of the conversation gets lost into terms of where that data actually diffuses out into the greater marketplace, and how space-derived data probably touches a lot of our daily lives much more than we actually think it does. I actually, without naming a client, about a year and a half ago, spoke with somebody, and they were talking something to do with GPS, and I made some comment about it being space-derived, and the person said, yes, of course it is. And then we talked about one or two other technologies, and it was the light bulb moment when they said, well, I understood that GPS was up there, but I never realized that the data that was being given to me in this specific use case was being derived from other Earth sensing and remote sensing capability. So I thought that was quite interesting.
Yeah, I think that's a great example. I mean, to push on this computing analogy, it would be sort of like internet from 95 to 2015. It wasn't because we put more fiber in the ground. It was because there were new applications, new software frameworks, new programming languages, new mobile devices, less about sort of just the underlying infrastructure. So I'm happy to see, and there's maybe we'll get to it later, there's many companies here that are making the enabling infrastructure easier, but the onus to get to $1 trillion, to me, relies on customer-centric entrepreneurs taking an industry that's sort of way outside of space and pulling in a little bit of space to make economic value out of it.
Oh, that's fantastic. Anything you want to add before we transition? All right, fantastic. So Sunil was great in pulling together some stuff. So the next part of the panel, we'll look at actually 5 key trends. Maturing Earth observation and new sensors. New space finally goes to geo. Enabling infrastructure strengthens. MilSpace meets NewSpace, which we'll talk more about this afternoon as well, and commercial human spaceflight. So to some of these topics, we've got some one-pagers and some quick insights in some of the companies that are doing that. And as we go through that, I'll invite the panelists to comment and provide their perspective on where they think it's going and what that could do to sort of driving the economic value. So we'll start with maturing Earth observation and new sensors. I mean, obviously, people are well familiar if you use Google Maps and you follow some of the stuff in the news about Digital Globe and Planet and other areas about what we can do from a commercial remote sensing perspective. There's been a lot of use of it, obviously, in the DoD space for decades, and the fusion of commercial remote sensing technologies into other daily applications is becoming more sort of prevalent by the day. So, one of the things that I think really haven't looked at from an outside of the industry perspective is what does it mean if you can actually, to Capella's Space's point, monitor changes on the planet every hour of every day? What does it mean to be persistent? What does it mean to actually be reliable? What does it mean to be, have a known cadence and a known data set that I can use in my organization as a non-space company? So Sunil, as you help put some of these together, I'll let you comment on these first.
Yeah, I think the idea here is Digital Globe 10 years ago, Planet 5 years ago, Skybox 5 years ago. There's only a few variables on geospatial visible spectrum imaging on refresh rate, revisit rate, resolution, and those have been explored and are in space or soon to go to space. So the areas that I'm seeing now have to do with new sensors, new capabilities, and as folks may or may not know, SAR is sort of a totally different sensor because you transmit a ton of energy downwards. Very different than just using passive detection. So there will hopefully be a few more new sensors, but I think in this category, there's pretty good coverage on standard Earth observation, and there's just a few more buckets of sensor technology. Capella, by the way, these slides are with the permission of the CEOs, no connection, and all public information.
Anybody else want to add anything?
Yeah, as we think about, I think you mentioned this just a few minutes ago. What are the other applications of this? So, what are the other, either customers or firms that customers that can benefit from some application of this that grow demand for this industry, or the other kinds of companies that can maybe do sort of on the periphery, just start doing something that's going to help benefit this from a core strength that they already have. We think, this technology. We think about, you mentioned SpaceX and OneWeb and some of the things they're doing. We think a lot about how this might change people's lives in rural America. People are moving to cities. This has been happening for a little while. It's a reverse trend of the last 50 years. There's no doubt about that. But over the next 50 or 100 years, we're still probably going to want to drink wine, and so we're going to have people out there growing grapes. We're going to have people that still live in some of those communities. And when we think about what are the ways or the pathways that you affect quality of life out there, help that farmer, help that agriculture producer, continue to manage, the crops, what kind of technology they're going to use. They're already using robots to pick apples off trees. What's the next thing? How do you manage some of these things? And how do you create, quality for folks out there that need access, need data, need information, still want to run a company, or, need a quality of life out there for education purposes. So there's some applications there that maybe aren't sort of on the vertical that we think about all the time, but from the state perspective, how is this stuff going to help folks? And that also grows demand. It might, help us grow the industry.
I think that imaging in particular is going to create a lot of efficiencies in the economy that will be externalities that you won't really necessarily see credited back to space. But when you think about things like just the ability of municipal planners or police departments to see which cars have been parked and have not moved for several days instead of having to go chalk all those tires, huge savings. When you think about the folks that maintain people's swimming pools for a living, now when they want to go market, they can not only see which houses actually have swimming pools, they can see whether my pool is turned green or not, and go hit the right market. Same thing with gardeners and all sorts of people. So I think this is going to deliver down into the economy a whole lot of benefit, and I hope we get the credit for it because, as Jeff mentioned, a lot of people don't realize where that data comes from. It's real important for policymakers to understand the value that space is already delivering and is going to start delivering in what will be mostly unseen ways.
I really just want someone to create the sensor or application that makes my traffic in Los Angeles better. That's my goal. Someone can do that and take credit for it, and I will be eternally grateful. So, second topic is NewSpace finally goes to GEO, and this is an interesting point because, as I mentioned about the sort of 27,000, 30,000 satellites that we benchmarked, I would say the bulk of them were all focused on some form of LEO, either ultra low LEO through maybe skirting the edges between low Earth orbit and medium Earth orbit. There were very few of the sort of far out time cycle ones that we're really looking at geo. And I think that this starts to become a bit transformative for us in terms of what can you do when the new space industry starts applying more agile innovation, more rapid development, and actually says, launch costs are coming down. We can affordably get out to geo and do something intriguing. And so, Sunil, I know you and I know John Conifay pretty well at Astronis, and it's exciting to see that this was actually they got a sizable investment by Andreessen recently, focused on a commercial geo concept. So I don't know if there's been another big geo one in the last 5 or 10 years.
Hopefully there are in this room, but as we think about 300 billion, my numbers will be off, so don't pin me to them too much. But about 100 billion, it's like comms, like mostly TV, internet from geo, and so far the LEO approach and the NewSpace approach, which often is predicated on commodity hardware with redundancy with multiple satellites, has not touched geo. Partially it's launch costs. My sense is launch is 50% more to get to geo, but more so a harsher radiation environment, needing to sort of go back to the one perfect satellite model versus like Planet Labs Inspire, 200 medium grade satellites. So Astronis, I think, is very interesting here to demonstrate that they haven't demonstrated it yet, but they're working on demonstrating that NewSpace and sort of the tinkering approach with cheaper hardware, moving more quickly, can finally touch into geo, and it. I think we'll see more interesting applications and a disruptive price point, and maybe more entrepreneurs can enter the geo space, because my sense is today geo is sort of still reserved for the heavyweights, and in the same way that back in the 1970s computers, you had to put gloves on to touch the computer. So hopefully geo will open up for NewSpace.
Yeah, I think there's some real opportunities in imaging, and I've talked to some companies who are looking at doing that in GEO rather than in LEO. I remember sitting at NASA and looking at the budget for Landsat and just shaking my head at, but why are we building this $1 billion thing with 30-meter resolution? And we're doing it because it's what we've always done. But I do think that the new technologies combined with optical communications let us put a lot more stuff in GEO and do a lot more exciting things out there.
I absolutely agreed. It's also nice to see some of the other uses of the sort of NewSpace, I'll say, paradigm or mantra in other applications. And just as a quick aside, I think it's for InSight that recently went towards Mars. There's actually CubeSats that are on it that they're looking for doing the data relay to improve mission operation on that. So it's nice to see sort of the stuff that we talk about here on a year-over-year basis at this conference sort of diffuse its way into other applications.
Yeah, I have to also say, policy-wise, I think there's a group of misguided policymakers who want to draw a circle around LEO and say this is commercial and everything else belongs to the government because you're not safe there, and we're going to protect you from it, and stay out until we tell you it's okay. Don't stay out. Get out there and go where you're going to go, and we need to make that happen.
Not to devolve too much into the policy debate, but just a quick aside on that one. Do you think that the renewed focus on sort of the lunar economy and the development of that will shift that sort of paradigm from a policy perspective?
Yes and no, interestingly. But I think in the long run, absolutely, that cislunar economy is where it's going to be, and it's going to be a commercial domain, and the role of the government is to provide rule of law and protection and help press some basic technology and R&D, but eventually it's a commercial zone. But clearly there's a couple of different ways of looking at it in the early time frame.
So topic number 3, enabling infrastructure strengthens. This is the ability of sort of the commercial industry to really either replicate, supplement, or replace aging technology that actually from an enabling perspective. So for those of you that may or may not know of Odyssey, it is, if I can boil it down to sort of a quick phrase, it's commercial TDRS, the tracking data and relay system that NASA uses for communications between the International Space Station, previously Shuttle, and a lot of their ground infrastructure and networks. And so 10, 15 years ago, I don't think you'd have anyone proposing, at least at a funding level, a commercial TDRS application, and yet now we see more and more people looking at what are these enabling infrastructure pieces that allow me to not have to build in some of this or double my constellation size just to be able to relay data. And when Odyssey or others are on orbit, they can potentially use it as a service, the same way that you have an ISP or something else. And I think that really sort of changes the paradigm in what you can do and where you can go.
Yeah, something you said there, you said it would be cheaper. I think it's important to recognize the benefits of this infrastructure. When I was at Bessemer, I invested a lot in developer tools, and this has a very strong parallel. Not only is it cheaper potentially to use Odyssey or Kepler, or maybe if you can even flip to the next slide, RBC Signals for sort of ground station service, but the idea is that, I'll run with the developer tools analogy. There's a Seattle company, Auth0, that I invested in a long time ago. These folks are total nerds about login and identity and authentication. You know, when you type your username and password. If you're building an app, you don't even care about the username and password section. You just want to get it and build the cool part of the application. Similar here. Generally, if you're building a satellite or constellation, you don't really care that much about certain elements, and care is sort of part of it. So I think it indicates the precision and accuracy that you're going to focus on different portions. So if you could have, I think Christopher and his team here, they're ground station nerds. And then Odyssey are RF in space nerds, and similar with Kepler. And so you want the best nerds. You get best of breed vendors for each segment here, and it's making it cheaper. It also makes it more robust, more scalable. You can deliver a better SLA to your underlying customers through the use of this stronger infrastructure. And it's taken a few years to get to this point, but it feels like, to me, poking around for 5 years now in this startup space, that we're now at the point where you could sort of pick and choose a few vendors and really move more quickly and have a more robust service, both lower cost and lower complexity.
Yeah, I think the vertical versus horizontal integration lessons to be learned in NewSpace are really interesting. We're in a very vertical mode right now with a lot of these companies that are designing, building, and planning to operate their launch vehicles, including the spacecraft attached to them. And I doubt that in a mature market that's the way the world looks, but it will be really interesting to see how much of this they choose to outsource once the expertise is available. In most cases, they went vertical because they couldn't find this level of expertise at any reasonable price. It was tied up by government contracts and either inaccessible or insanely expensive because of the way the government did business. And now that these companies are emerging as pure private players, it'll be really, really exciting to see the economies of scale that come out of that.
And enabling infrastructure isn't just limited to things like Odyssey in space or RBC signals on the ground. I mean, I think it also is everything else that you can build and derive, whether that's rail or transportation, things that can enable the transportation of goods and components to make up some of these things. So, Chris, from your perspective at a state level, what do you see as enabling components that you can do from a state perspective for something like this in the industry?
Yeah, so I mean, I think the state's got to understand its role and what it does is from a regulatory perspective. I mean, the federal government certainly has that role too. But when we think about the approach we've taken with the data needed for autonomous vehicles, we're hopeful that there will be additional autonomous vehicle testing here. But the approach has been to not regulate that, to let that industry thrive and grow sort of organically. So we hope that's the right approach. We hope we can continue to evaluate approaches like that to allow these technologies to improve a little bit. I think the more we can create a system or an environment here where you can have multiple different firms improving these various technologies, I think is really going to be a great value. And again, it's sort of this notion that this role the state has, this role that we have, and thinking about how do you make a person's life better? How do you make a consumer's life better? How do you make somebody's life easier that's out there with not a lot of access to resources? The more of these technologies that can improve, and then the more economical they can become, will be a great value to just terrestrial communication. The derivative technology that might be created by some of these. Right now we have this major problem. Every state in the country has this problem with rural broadband, and we have these sort of archaic solutions of how much more fiber can you put in the ground? What if you had $50 billion? That's not enough, even to get to solve the problem that we have today. And so, what are the other ways where network technology can improve that make the economics work? Even if we had money right now to put all that fiber in the ground somewhere, the economics still don't pencil because it's hard to get somebody that's at the top of Mount Rainier to pay $100 a month for a broadband connection. That's not what they're interested in. So as the economics improve, as this technology improves, I think it's a good thing that we can look at how you create a system where you have flexibility in the regulatory perspective for companies to be able to serve people and get people access to information they need, hopefully derived from some of the technologies that are growing here.
Absolutely. So the next one, the sort of the components that we're looking at is MilSpace meets NewSpace, and this will be talked about in quite a level of detail later this afternoon, so I won't steal that panel's thunder. But one of the things I should say is I screwed the title of this up. It really should be the inverse side of NewSpace meets MilSpace. And the reason I say it that way is for the first time in a very long time, I think there's actually better mechanisms for the new space industry to engage with the military and the various branches of the DoD. And one of the greatest examples of this is the Space Enterprise Consortium OTA. For those of you that aren't familiar, it's another transaction authority that the U.S. Air Force has set up that allows for rapid prototyping and the ability for smaller, maybe non-traditional players to sort of get their prototypes into the U.S. Air Force. Everyone that I know in this industry from the commercial side that knows about the spec OTA has been watching it very, very closely. There's a lot of enthusiasm around it. There's a lot of sort of thought that this could finally be the time that I could sell into this. And if you've got the sort of natural equilibrium sort of being driven towards where I'm naturally creating a product or a service that benefits the commercial industry, but I can also sell it into the military, I think that starts transforming some of the economics and the value that you can derive from a customer base, especially for these companies that had purposely said we're not going to go after government contracts for whatever the right reason might be in that case. So I think the biggest challenge that we would have in terms of driving a greater economic change in the new space meets MilSpace part of that conversation is just getting people evangelized that there are mechanisms out there that NewSpace can take advantage of. And lastly, we'll go on to commercial human spaceflight. And Greg, I know this is a topic that's near and dear to your heart, so I will let you actually talk about this, or at least start this part of the conversation about what this can do from an industry transformation and an economic impact.
From my point of view, I don't think there's any purpose in space if it doesn't involve people. I love the robots. I love what JPL does every day, and I want to see that continue. But if we don't take humans to space, I don't think it's valuable. And I think commercials, obviously, the only way that's going to happen. I think it will be a surprising driver. I have a lot of confidence in companies like Axiom and Bigelow to actually fill those space stations if we can get through the short-term issues of funding and government support and or regulation that keep them from doing it. I think that we will see that space tourism is a much bigger market than people think, both in the suborbital and the orbital market. I had a lot of people say to me, well, that market's going to peak up and then it's just going to be gone and it's going to go away. And entertainment drove the early computer industry, and I think you'll see that to a great extent it can drive the human spaceflight industry as well.
I think just not necessarily from a state perspective, but just from a personal perspective. I think there's something about this industry that has captured folks' imagination. So it's not similar to the businesses I visit that are in the check printing industry. We're looking at a much different future. But the twinkle folks have in their eye when they think about space flight, when they think about space exploration, I think is something that shouldn't be ignored or dismissed. For folks to for kids right now to grow up and think about what path am I going to take. What am I going to be interested in? I think the notion that we have some aspiration here for human spaceflight, isn't insignificant. It is in fact critical. Just even the last 50 years, that inspiration has been a big driver for us to continue this effort. I named my oldest daughter Kennedy after the President Kennedy. Because of that inspiration, because a lot of the things that he did, and specifically around this issue. And so I think that's a component. We're all human. We have emotions and passions. I think to make sure we keep that as an aspiration helps grow, helps us in all elements, helps us on a policy level, helps us on an education level. And so I appreciated your comments because I think it's critical that we keep that as a priority.
At the ISDC conference a month ago, I showed a slide when I was talking about space tourism, and people said to me it's dangerous, it's expensive, and people won't do it more than once. Well, I found a news story that day, and the title was, Japanese man who lost 9 fingers on 8 previous attempts to climb Mount Everest dies on 9th attempt. And that was a true story. And I think that just says something about the human determination to overcome those particular obstacles and to participate and explore. And I think that the sovereign astronaut program in the tourism industry will be much bigger than people think.
Can I break form and just ask you a question about that then? So are there any upcoming technological changes that will drive down the cost? It seemed to me from the outside that it was roughly $100,000 to do either a short jaunt or a little bit longer trip with Worldview or Virgin Galactic, and curious if a major cost reduction is part of that goal, and if it's coming from any technological reason.
Yeah, well, I think it's not the cost side of things that will determine what the price is, of course, because it's a market. It's the demand side of things that will determine. But once it gets competitive, which I hope it does, yeah, I think we see rapidly decreasing prices. I don't think it gets anywhere near the few $100s that an airplane ticket is, but there's no reason that I can see that we can't build vehicles that are relatively close, at least for suborbital, to the performance of a commercial jet aircraft. And so I wouldn't be surprised to see this in the low tens of thousands of dollars in a relatively short period of time. Orbital will be more interesting, but there's still a lot of nations that want to send their astronauts, and a lot of people that are wealthy enough to pay millions and hopefully eventually hundreds of thousands of dollars for that experience.
And I guess it's worth noting, Dylan Taylor, who many of you must know, has a nonprofit called Space for All, and the goal is to have more people experience space. And I think one of the bases is, if you're a farmer in India, when you see someone in America that doesn't look like you or talk like you, go to space, it's not an emotional connection. So a little bit of the commercial human spaceflight piece, I think, is the emotional piece. And so the goal is to send a diverse set of people, I think hundreds of people up to space on these vehicles. The other thing worth noting,
I think that's really important. And we also need a academics to space program as well.
The other thing is, I know I was taking the bear case, but I watched this TED Talk like 3 times, Gwynne Shotwell's TED Talk, about the BFR rocket doing intercontinental travel in 60 minutes to go from here to Hong Kong. And she said it, and I watched her body language. She looks very, very serious. She said, absolutely, within 10 years, they will be sending hundreds of people for about the price of a normal airline ticket. And so maybe this doesn't end up getting bucketed as tourism versus just utility travel. But either way, you get to see the curvature of the Earth and go on a rocket ship.
And cargo, too, that fresh tuna from Japan coming in every morning.
Yeah, that all sounds fantastic, and I would love to sort of see that happen. For those of you that know me pretty well, I sort of harp on about structural change nonstop, and to some of you, my sincere apologies, because you probably hear it way too often. But as we talk about commercial human spaceflight, I mean, that's one area where I'm really excited to see whether it's lower launch costs, higher cadence, more regular sort of commercial reliability in the service, and that could be from any provider. I mean, I'm not trying to pick a winner over a loser in any way, shape, or form there, but just seeing sort of that entire industry, both from a supply piece and also the incentivization of the demand come up. I'm really excited to see where it goes, and I agree with you, Greg. I think it's going to be surprising what the market actually looks like for something like that as it does play out. So we're near the end of the time, and I do want to give people a few minutes to ask questions. And as aside, we do have more microphones that people can pass out. But if the 3 panelists are willing to indulge me on this last question, we talked in the beginning about the 2040s being when we might reach $1 trillion market. If you're willing to state this publicly, what's your opinion, before or after? And we'll just go down the line. Sunil.
I think I've met with many of you as a pitch, and I hate market size numbers, I hate Gartner numbers. So no offense to Gartner. So I'm the least excited about answering this question. I like bottoms up. I like meeting individual people, talking about individual customers and specific problems, and working my way up to trillions of dollars as opposed to sort of hand waving. But to hand wave, I would say before 2045, if you're saying 2040s, before 2045, so within 25 years, yeah.
Before or never, unfortunately.
I don't know enough about the subject, so I'll take a government approach, be very conservative here. I'd say after, but I think the work that they've done to point out sort of what some of those prognosticators think we may be at, I think is good direction to input for us to think about what's possible and help that drive some of the decisions we make, and for the state, how you build the workforce, how you create ecosystem, how you build environment. So hopefully it's before. If I had to bet on a roulette table, I would say after.
And I'll answer that one. I'm pretty skeptical about a lot of things in this industry, but I will still say before, and hopefully well before. So with that, if anyone has any questions, I think there's mics floating around somewhere. You're more than welcome to ask the panelists. We've probably got time for 2 or 3 questions. Or lunch.
Good morning. So a lot of the big exciting economic drivers and expansion that you've been talking about still puts the customer base firmly on Earth. But there are a lot of people who are talking about expanding Earth's economy into the solar system, creating a truly space-based economy. How do we move? What are the key inflection points that need to happen in order to shift from an Earth-based customer base to a space-for-space economy?
Commercial human spaceflight.
Yeah,
You've got to have people there.
Yeah, I would agree with that. And to a conversation, I think, Greg, that you and I were having yesterday, the ability to actually commoditize pieces of whether it's hardware or operational pieces or infrastructure so that you can actually do futures and other sort of normal financial instruments against it, I think definitely help from growing the economic case that closes some of the business cases of sending people further out into the solar system.
Yeah, it's a really, really tricky question. I'll say most, it's dangerous, but I'll speak on behalf of most VCs poking around in space right now. Most VCs are set up as sort of a 10-year partnership, so they need to sort of invest, grow the company, and sell within 10 years. And so many of these space-for-space opportunities are outside the purview of that. That means within sort of 5 years, could it result in meaningful revenue and even potentially be a sale? Not that that's the goal. The best companies like Facebook take 15 years to sell, but that has precluded a lot of the asteroid mining and other sort of space-for-space opportunities.
Jeff, you mentioned a report early on in your talk that was available, or Bank of America, I think, to read. Can you make that available on the app or something?
I don't know if I can personally make
link?
it available on the app. I'll talk to the Space Frontier Foundation people. But if you Google Bank of America Merrill Lynch Space Primer, I believe you can find it. It is a public and open source. One over there.
My other favorite report is the Satellite Industry Association report, put together by Carissa and her team at Bryce. But SIA report 2018 is fantastic.
Yeah, that's a very good one too. And then just as we're talking about reports, the nice part is we're seeing more and more of them come online. So I think every year you're probably going to see the number of people studying this sort of industry and the impacts from a variety of different perspectives, whether it's the Satellite Industries Association or Bank of America for thematic investing, or even the global space study that we kicked off yesterday with Space Frontier Foundation. There's going to be different and more viewpoints, and I think that helps tell the industry story and helps really give the sort of ammunition to look at this from multiple angles.
Sorry to hold you guys between lunch. I thought this was a great panel, and one thing that I didn't see you really touch on was the aspect of the human space flight exploration being, human exposure to radiation, and a barrier that a lot of people are like, oh, we don't want to get on a one-way trip to Mars or stuff like that. And I had a long conversation over dinner last night about this. So I'm wondering, what type of technologies or advancements in human health and human restoration do you think need to happen in order to enable human space flight? And what have you seen in the industry happening in this sphere to really enable this?
Yeah, certainly you can't underestimate the challenges with deep space exploration and habitation, radiation, the ability for human beings to reproduce in zero-G. These are all very serious issues. We don't have time within this panel, I think, to address all the technologies, but there are a lot of very interesting ones out there. I can say, having looked at them while breathing through a fire hose at NASA for a few months on the transition team, and be glad to take that offline. But it is a huge issue, but not insurmountable.
And you may know our Jeff Feige had a space suit company, so you can ask him about that later as well. I'm sure he'll have a lot to say about it.
All right. Well, on that note, I'm going to let everyone go to lunch. So please join me in giving me a big round of applause for the panelists, and thank you for your time this morning.